My name is Darlene Bennett, and I have been teaching for 24 years. I teach grade 5 at St.Edward School in Calagurus. There are 14 girls and 9 boys in my class.
My name is Howell. I have been teaching for 8 years in French immersion. Currently, I teach an ICF class at Goulds Elementary. The class consists of 21 students, 11 boys and 10 girls.
I'm Karen Adams, and I've been teaching for 20 years and presently teach a grade 6 English class at Goulds Elementary. This year I have 28 students, 8 girls and 20 boys with varied abilities. I have 2 on a modified program, 2 on an alternate program, 24 in the prescribed program, with 15 of those having diagnosed LDs.
Science is a personal area of interest of ours. We believe that learning through a hands-on, minds-on approach improves student learning and thinking. We believe that student engagement and reflection is essential in the learning process and is a critical factor in encouraging higher-order thinking. We believe that all students can succeed and learn regardless of ability.
As teachers, we wanted to use teacher inquiry as a research method to see how we can best approach science. In general, science has been a challenge for many teachers to deliver a meaningful science program. Instructional methods have evolved from previous years into inquiry-based learning. Considering the diverse nature of students in the regular classroom today, we questioned if we are able to develop higher-order thinking in science, and would we still be able to meet the diverse needs of our learners.
We decided to select the physical science units in both grade levels and develop these units with higher-order thinking in mind. Taking the latest research on a revision of Bloom's taxonomy from Anderson and Crothwell, we examined the progression of higher-order thinking and designed our investigations, questions, and instruction to determine whether or not we would be able to see higher-order thinking in our students.
For the purposes of this project, we had 3 main research questions. As teachers, can we effectively use guided inquiry and formative assessment to develop higher-order thinking in students in science? Will students develop higher-order thinking skills through the use of guided inquiry and formative assessment as a method of instruction? And will students' attitudes and interest in science improve by using this method? These questions guided our planning, implementation, and assessment of our science units throughout this project. Parents were given a letter explaining the nature of the project and signed consent forms to allow their child to participate in the research. We met several times throughout the year with 2 MUN researchers who have been investigating this concept. They acted as mentors and assisted us in developing our units, analyzing the student work, and subsequent focus of explicit instruction.
The lessons were determined by the major concepts and were completed in 5 cycles. Lessons were hands-on, minds-on, and each student was given a science kit containing all materials necessary. The formative assessment tasks contained questions which required understanding and higher-order thinking. The cycle began with 2 60-minute lessons of guided inquiry. The students were presented with a problem and completed the investigation individually or in pairs. The lessons were designed to have the children work through the investigation without having the teacher to demonstrate or tell them what to do. Carefully worded prompts, which were constructed to still have the students solve the problem independently, were used only after sufficient time had elapsed. After each investigation, the students wrote their own ideas of what was happening in their science notebook. They wrote responses to what they did, what they saw or observed, and why they thought something happened, as these statements form the basis for all science inquiries, procedures, observations, and conclusions. Students later included other skills in science such as charts, diagrams, and record-keeping techniques. Students had opportunities to respond and reflect on specific questions, as well as refine their answers and add further learning.
During the formative assessment task, students were given a set of questions based on ideas and concepts learned during the previous 2 classes. These questions required students to take knowledge and concepts from the experiments and apply them to a new situation. The responses were analyzed, which allowed us to determine the degree to which students understood a particular concept, and to see if any development of higher-order thinking was present. This also allowed us to determine any misconceptions or incomplete understandings the students may have had. The responses were also used to create a series of strongly constructed answers to share with the students to analyze as a group, and this information guided our explicit instruction. At the beginning of this lesson, a discussion around the specific levels of higher order thinking and Fran's Guide for Critical Thinking were systematically introduced. Students were led through these concepts and were guided through how the concepts related to science in their own lives. Then, as a class, they examined the responses and identified the particular aspects which made it a strong response, specifically looking for clarity, accuracy, and examples that showed deeper understanding. Sometimes an interactive demonstration was used to clarify an idea, and students were given an opportunity to improve a response for a particular question.
We used a variety of research methods to collect our data. We administered a student questionnaire, which enabled us to determine students' prior attitudes of and interest in science based on their previous experiences. It was re-administered at the end of our project for comparison, and significant changes in students' attitudes and interests were noted. We also used a co-teaching method whereby one teacher would take the lead in their own classroom during instruction, and the other teacher would assist, take notes, and observe while students worked. This approach allowed the lead teacher to focus on instruction and guidance. These notes helped us to discuss the day's lesson in greater detail in order to give us a better picture of student engagement. It also allowed us to more accurately guide the planning of subsequent activities, as we were able to see exactly what worked and what didn't.
We learned many valuable concepts which will improve our future instruction with the teacher inquiry research, as it became the most beneficial professional development in science that we have received in a long while. We not only improved our understanding of the science concepts we were teaching, but also renewed interest in ourselves as science educators. Our instructional method allowed us to choose the most effective investigations that would be appropriate for the children to complete and get at the concept we wanted them to understand. There are many investigations that could have been chosen, but the analysis of determining what was the desired learning and which was better suited enabled us to learn more as we went along. Choosing the prompts to accompany investigations also gave us the opportunity to consider possible dilemmas the children may encounter and provided us with an outlet to have the child continue with discovery and learning. The structure we had as teachers, juxtaposed with the openness of the student participation, created the best possible learning situation.
This approach encouraged the development of important skills for science inquiry, problem solving, and decision making. The activities provided students with opportunities to understand and practice the skills and procedures of science in a child-centered way. Each child participated. Each child tried things that worked and things that didn't. Each child had to solve the problem independently. Each child was hands-on, minds-on. Each child met with success, and each child felt pride in their accomplishment. The Science Notebook established an organization for the processes needed in creating, performing, and reporting science experiments independently. Creating their own diagrams allowed students a second way to further their understandings of the concepts. The formative assessment task presented the students with scenarios which challenged them to apply or evaluate their knowledge of the previous lessons. Being able to apply or evaluate knowledge shows higher order thinking.
We could assess each child in the way that best allowed them to demonstrate their learning and depth of their understanding in a fair and equitable manner, even those on modified and alternate programs. These children participated and enjoyed science as much as the children on the prescribed program. They experienced success and volunteered to share in discussions and presented competent responses. The increase in participation in guided discussions provided another opportunity to assess learning. The Science Notebook, written in the children's own words, showed clear insight into their understanding. The formative assessment tasks contained questions which identified who had transferred their understanding into a higher level of thinking. Each child was able to grow as a learner and thinker. Ultimately, we found it easier to assess and evaluate student learning and complete report cards.
Students' attitudes and interest in science definitely increased. Students began asking about science and were eager for the next class to occur. The confidence and self-esteem of the students was obviously increasing, especially for the most challenged of our students. Each child, no matter their program, learned. Not every student achieved the higher levels of thinking according to the taxonomy, but there was an increase in their personal levels. For us, that was still a significant finding. Overall, we were astounded at how much learning had actually taken place and that the majority of our students were able to show higher order thinking by correctly predicting outcomes of scenarios and providing accurate explanations in their responses.
This project has broadened and enlightened our understanding of teacher inquiry. We realize that in order to improve our teaching, teachers need to be able to investigate ideas in authentic situations. One of the strengths of teacher inquiry is that it allows you to have the focus of research and gives you a genuine setting. We were able to streamline our focus and concentrate on the students' incomplete understandings, making us able to meet the diverse needs more efficiently within our classrooms. One of the disadvantages of the teacher inquiry is the amount of time needed to review the literature and to prepare effectively for science. Planning and preparing the science is required as part of regular teaching. However, to make it as effective as we found using this approach takes time that is not available to us. The advantage, however, is that we now have 2 excellent science units complete for the coming year. And perhaps most successfully of all was that all students learned and developed a more positive appreciation and interest in science education.